Okay, let's look at this question. A non-uniform electrical field. This is keyword. It's quite important. Again, it's asking the electric flux. I know the flux equal A multiplied dA equal Q inside over epsilon 0. But here you can see there isn't charge information. So if there isn't charge information, I can't use this one. I have to use this information. But normally, if the electrical field is uniform, and the shape is symmetric, you don't need to take integral. Just you can say flux equal A multiplied surface. E multiplied surface, sorry. So you can take the direct flux with that formula. But unfortunately, it says the electrical field is non-uniform. How can I take it? You need to take the integral. You need to use that formula with using the integral. Let's continue. Okay, we will use this formula. I know the electrical field, but I need to describe the surface area, I mean the dA. How can I surface? Normally, I know on the rectangle system, on rectangle material, I can describe x, this is x, and y. But it says find electric flux flow through a rectangular surface extending from x to x equals 0 to x equals w. It means we will take integral on the x coordinated system. Okay, so you can write here, if I take the derivative for both sides, you can write y dx. Y is here, look at here, h, y equal h. I will write this one. Also, I need to describe its unit vector. What's the unit vector? Be careful. X, this is x, and this is y. I can say x and y. The A vector always perpendicular to that surface. So the A vector must be on here, on the z axis. Can you see? So I can use, A equals K. So K is z vector, z axis vector. Don't forget its unit. Now, time to write everything. Instead of h, I will write, instead of y, I will write h. Electrical field is y, this is y, okay, plus bz, z, and cxk multiply y dx k. I want to get rid of from here. Maybe I can clean this part. Okay, now I will take the integral using dx. The integral based on dx. And also it gives the limitation. It starts from 0 to w. You put this part. Don't forget for when we multiply with the scalar vector. I know I multiply I, or z multiply z, or k multiply k, it gives 1. But if you multiply with the different unit vector, it gives 0. Also z, it multiply k. So when you multiply with this one to, don't forget to its unit vector with the k, of course it gives 0, because I multiply k gives 0. So when you multiply z to k, of course, by k, it gives 0. So finally, you will just have this part, because k multiply k gives 1. This part, k multiply k, gives 1. Okay. Now we can take the integral 0 to w. I have just instead of y, I will use h and c x d x. Did I forget anything? I will check. I will take the c instead of y. I take this one. Okay. So this part is constant. You can take the outside of here. From 0 to w x dx. I know its integral result gives x to power 2 over, give me a second, 2. I need to put its limitation as well. hcw square over 2 minus hc 0 square over 2. Your final result, this part. So your result, flux result, equal to that